Right. Good morning, everyone. So this is the fourth video of our lesson, quadratic equations. So in the last lesson, we have discussed about the quadratic equations and the behavior of quadratic functions. Right. Then we have done some simple questions regarding that part. Now I'm going to go into the next part of that lesson. Right. And now let's write down the next subtopic. Write down developing a quadratic equation. Developing a quadratic equation using a quadratic function. Using a quadratic function. Right. Now let's consider the quadratic function fx equal to ax square plus bx plus c. Now we have discussed about these functions deeply in the previous 3 lessons. Right. So here a comma b comma c are real numbers and simple a is not equal to 0. Right. A is not equal to 0. Right. This is a quadratic function, and here we know the determinant delta x equal to b square minus 4ac. Right. We have discussed about delta x in the previous video, so you can watch that. Right. So if you draw this function, this is the shape of this function, right? So fx equal to x square plus bx plus c. This is the quadratic function we are going to talk about. Now we have drawn several graphs of several quadratic functions in the previous videos, previous lessons, so you can watch them. Now in here, fx equal to x square plus bx plus c. Right. So if you draw the function, it looks like this. This is the quadratic function fx equal to x square plus bx plus c. So here I am drawing the y-axis, y. Here we can draw the x-axis, x. Right. So this is the quadratic function fx equal to ax square plus bx plus c. So I can write down this as y equal to ax square plus bx plus c. This is the quadratic equation, right? So now look at this. This is the function of this quadratic equation, and if you look at this quadratic function will intersect the x-axis in 2 points, 2 different points. So those 2 points are the roots of this quadratic function when this quadratic function equal to 0, right? So if you consider this line, this is x-axis means y equal to 0 line. Y equal to 0 line is the x-axis, right? So here, if you take any point in this x-axis, y coordinate is 0. Y coordinate is 0. If you take any point in this x-axis, y coordinate is 0. So this is the y equals 0 straight line, right? So when y equal to 0, there are 2 values for x. First one is we can take that as alpha and beta. So these are the 2 values when y equal to 0. Right. So I'm going to write down that when y equal to 0, then this fx becomes 0. So we can write down 0 equal to ax square plus bx plus c. Right. Ax square plus bx plus c. That means ax square plus bx plus c will be equal to 0. So if you simplify this quadratic equation using the computing square method, you will get 2 answers for x. You will get 2 solutions for x because there are x square terms, right? So if the 2 solutions, we can call those 2 solutions as roots. So the 2 solutions will be x equal to alpha and x equal to beta. So those are the roots of this equation. So this is the roots of the equation, right? So when y equal to 0, when y equal to 0. So this is the quadratic function we are using here. This is the quadratic function. Now using this quadratic function, when y equal to 0, we can develop one quadratic equation. So this is the quadratic equation we have derived from this quadratic function when y equal to 0. So roots of this quadratic equation are x equal to alpha and beta. So these are the intersection points of this x-axis. Right. Now I will take another straight line. Here I will draw a straight line like this. So here I am going to take, this is the, here y value is 1. And the intersection point of this graph with this straight line, I will take that as gamma and delta. Right? Gamma and delta. Right. So I will take this straight line as, so here y value is 1. So if you take this straight line is parallel to x-axis. This straight line is parallel to x-axis. So every point in this straight line has the same y value, that is 1. So y value of this straight line is equal to 1. Therefore, we can write down this equation as y equal to 1. Right? This is y equal to 1 straight line. So intersection points of this y equal to 1 straight line are gamma and delta. So those are the roots of the equation. We will see what will happen when y equal to 1. So this is fx equal to x square plus bx plus c. So when y equal to 1, look at this, when y equal to 1, I can write down here this part equal to 1, 1 equal to ax square plus bx plus c. Now I can take 1 to the other side. Then this equation will become ax square plus bx plus c minus 1. I will take that, I took this 1 to the other side. Now this is also a quadratic equation, right? This is a quadratic equation when y equal to 1. This is a quadratic equation. So this quadratic equation, we have developed this quadratic equation when y equal to 1. We have developed this quadratic equation when y equal to 0. Right? So we can write down the roots of this equation as x equal to gamma and x equal to delta. Right? So in this way, when y equal to 0, when y equal to 1, when y equal to minus 1, y equal to 3, you can develop any number of equations using this single quadratic function. Right? So this quadratic function can make infinite number of quadratic equations. So we just have to give a value to the y. Right? So I will take another example. So right. So I will take when y equal to 0, 1, 2, 3, 4. We can make a number of, right? So here I will take this value as k. Then this straight line, I will name that straight line as y equal to k. So this is the y equal to k straight line. So these are the two intersection points. I will name that as lambda and mu. Lambda and mu are the two intersection points of this straight line with this graph. Right. Now look at this. Right. Now look at this. When y equal to k, we can develop another equation from this, and the same way we have developed these two equations. Right. So when, now look at this, when y equal to k, when y equal to k, we can write down k equal to ax square plus bx plus c. Now if you take k to the other side, ax square plus bx plus c minus k equal to 0. Now this is a quadratic equation. This is also a quadratic equation we have developed from this quadratic function. Now roots, we can write down roots of this equation as x equal to lambda and x equal to mu. X equal to lambda, x equal to mu. Those are the two values of x or the roots of this equation. Right. Now you can see that we can make infinite number of quadratic equations using one single quadratic function. So we just have to equal that y value to another function, right, or another constant, right. We can also equal this y value to another function. Then also we can make another quadratic equation, right. For example, look at this now. So this is the quadratic function we are going to take. Now we have developed several quadratic equations from this quadratic function. Right. Now look at this. Now I will take that quadratic function again. This is the quadratic function. Here I am drawing y-axis, and this is the x-axis. Right. So this is the quadratic function f(x) equal to ax square plus bx plus c. Now I will draw a straight line. I will draw a straight line like this. Right. So look at this. I will draw a straight line in this way. Right. So I can name this straight line y equal to y equal to lx plus m. So this is a straight line. Y equal to lx plus m. So here there are two intersection points. This is the first intersection point. This is the second intersection point. Intersection point of this graph fx and this straight line lx plus m. Right. There are two intersection points. I will take that intersection points as alpha comma beta. Let's take that intersection points as alpha comma beta. Right. So when these two equations are when these two functions are equal, first fx, this is the quadratic function, and this is lx plus m, this is a straight line. So when these two are equal, we can equal them separately. Right. If these two are equal, I will name this as gx. I will take this function as gx. So when fx equal to gx, we have ax square plus bx plus c equal to gx means lx plus m. So I will take all the values to the left hand side. Then ax square plus b minus lx plus c minus m, that is equal to 0. So this is also a quadratic equation. This is also a quadratic equation. So if you take the roots are x equal to alpha and x equal to beta. So there are two roots. These are the two roots when these two functions are equal. Right. So in this way, we can develop any number of quadratic equations using a single quadratic function. Right. So that is the part I have to explain. Now, now look at here. I will go to the next part. Before going to the next part, let's take this equation again, this function again. Now consider this function again. Here I am going to consider fx equal to ax square plus bx plus c. So this is a small theory part. After that, we are going to do the questions, right? So first, consider this function fx equal to ax square plus bx plus c. So here, delta means the determinant equal to b square minus 4ac, right? So first look at this number one. So right, when delta is greater than 0, when delta is greater than 0, we can draw this function. This is the x-axis. When delta is greater than 0, we know that there are two roots. We have explained that there are two roots, so this can be the two roots, right? That means two intersection points. So this is the fx function, fx, or this is the fx. There are two roots when delta is greater than 0, right? So when here this is the x-axis, or y equal to 0 axis. This is the x-axis, or y equal to 0 axis. So when y equal to 0, from this fx function, we can develop a quadratic equation, right? So when, look at this, when fx equal to 0 or y equal to 0, we can develop a quadratic equation, that is ax square plus bx plus c equal to 0. So when delta is greater than 0, this quadratic equation has two roots. This quadratic equation has two roots when delta is greater than 0. Right. Same way, what will happen when delta is equal to 0? Now, number 2, what will happen when delta equal to 0? Right. When delta equal to 0, if you draw the functions, this is the function look like. This is the way that function look like. So there is one intersection point, or one point where the function touches the x-axis, right? So function is, this is the function fx. Here this is the function fx, and this is the x-axis. That means y equal to 0 axis. So when y equal to 0 or fx equal to 0, from this function we can develop a quadratic equation ax square plus bx plus c equal to 0. And this quadratic equation has only one solution or one root when delta equal to 0. When in the previous situation, when delta greater than 0, we had two solutions. Right. Next, third one. Now look at this third part. When delta is less than 0. When delta is less than 0, if you draw the graphs, this is the x-axis. This graph will lie above the x-axis or lie below the x-axis. So there are no intersection points, right? So when fx equal to 0, here also we can develop a quadratic equation ax square plus bx plus c equal to 0. Now there are no intersection points in this quadratic function, quadratic equation, right? So these are the three situations, and these are the three types of quadratic equations you can develop from this quadratic function, right? I think you have understood that. Now we can go to the next part. After that, we can do some questions in this lesson. So we are doing the last part of this lesson, quadratic equation. After that, we can go to the next parts, factor theorem, remainder theorem, inequalities, and so on. After that, we can go to the next lesson. Right. Now, let's write down the subtopic. Write down in red color. Relations between the roots and the coefficients of a quadratic equation. Relations between the roots and the coefficients of a quadratic equation. Right. Now, look at this quadratic equation. X square minus 7x plus 12 equal to 0. Now, this is a quadratic equation. Now we can use the computing square method, right? Take the x value without the square, minus divide the coefficient of x by 2, take the square of whole thing, minus the square of this constant, 49 over 4, plus the remaining part, 12 over 1 equal to 0. Now simplify this, x minus 7 over 2, square of the whole thing, minus 49 over 4, plus multiply the numerator and denominator by 4. Then 48 over 4 equals 0. Now x minus 7 over 2 square of the whole thing minus 49 plus 48. That means minus 1 over 4 equals 0. Right? Then x minus 7 over 2 square of the whole thing minus 1 over 4 we can write down as half square equal to 0. Right? Now we can separate into factors. This is the difference of two squares. First factor x minus 7 over 2 minus half. Second factor x minus 7 over 2 plus half equal to 0. So simplify this, then x minus 7 minus 1 minus 8 over 2 means minus 4. Minus 7 plus 1 means minus 6 over 2 means minus 3 equal 0. So if you separately equal these two factors to 0, x minus 4 equal 0, x minus 3 will be equal to 0. That means x equal to 4, x will be equal to 3. Right? So these are the roots or the solutions of this equation. Right? This is the quadratic equation. We can simplify and find the two solutions. Right? So we call them as the roots of this equation. Right? So roots of the equation x square minus 7x plus 12 equal to 0 are x equal to 4 and x equal to 3. Those are the roots. Right. Now look at this. X square minus 7x plus 12 equal to 0. Roots are 3, 4. Right. So I will take this side as the left hand side of this equation and this part as the right hand side of this equation. Right. So write down a point in red color. Write down a special point in red color. Write down the roots of any equation will satisfy that equation. The roots of any equation will satisfy that equation. Right. So what do you mean by that? So let's see. So here the roots are 3, 4. So if you take value 3 when x equal to 3, look at the left hand side. Left hand side equal to, when x equal to 3, left hand side you equal to 3 square, that means 9 minus 7 into 3, that means 21 plus 12. So if you simplify, this will 9 plus 12 is 21 minus 21 equal to 0. So left hand side will be equal to 0. That means left hand side will be equal to right hand side when x equal to 3. Right. So next take the next root when x equal to 4. Right. When x equal to 4, let's take the left hand side. So 4 square means 16 minus 7 into 4 means 28 plus 12. Right. 16 plus 12 is 28 minus 28 equal to 0. Here also left hand side will be equal to right hand side. Right. That means this equation will satisfy their roots, its roots. Right. So x equal to 3 means the roots of root of this equation. X equal to 4 is also a root of this equation. So if you substitute the value of the root, then it will satisfy the left hand side and the right hand side. Right. So only the roots of a equation will satisfy that equation. Right. Okay. Now look at this. So this is an example. So if you take a standard equation, let's see what will happen. So look at this. Let's take a quadratic equation ax square plus bx plus c equal to 0. Here, let's take roots alpha comma beta. Right, roots are alpha comma beta. Right. Now, look at this. When x equal to alpha, we can write down, we can substitute the roots because we know from the previous example, roots of a equation will satisfy this equation. Right. So here roots are alpha comma beta. So alpha will satisfy this equation. Right. So here a alpha square plus b alpha plus c equals 0. I will take this as number 1. So when x equal to beta, that also beta is also a root. Therefore, it will satisfy this equation a beta square plus b beta plus c equal to 0. This is number 2. Right. So in the questions, when we are doing questions, this is very useful to simplify the question and get the answers. Right. So the roots of a equation will satisfy that equation. That is the point in here. Now let's go to the next part. Right. Okay. After that, we can go to the questions. Right. Next, write down subtopic. Write down finding the equation when the roots. Finding the equation when the roots of a quadratic equation is given. Finding the equation when the roots of a quadratic equation is given. Right. Write down the first question. Find the quadratic equation with roots 3, 4. Find the quadratic equation with roots 3, 4. Right. Now look at this. 3, 4. That means x equal to 3, x equal to 4. These are the roots. So in the previous example, we have so that in the previous example we saw that from when a quadratic equation is given, we can simplify and find the roots of that equation. Right? We can simplify a quadratic equation and find the roots. So here, this is the reverse process of that. The roots are given. Here the roots are given. Now we have to find the quadratic equation. Right? So this is the method. So x equal to 3, take the 3 to the other side. Here take the 4 to the other side. Then this will become x minus 3 equal to 0. Here x minus 4 will be equal to 0. Now we can multiply these two. Then x minus 3 into x minus 4 will be equal to 0. Right? So now expand this. If you expand this, x square minus 4x minus 3x, that means minus 7x. 3 into 4 plus 2. So this is the quadratic equation. Right? So when the roots are given, from this method we can find the quadratic equation. Right. So it is a simple process. Write down next example. Write down find the quadratic equation. Find the quadratic equation with roots alpha comma beta. Second one, find the quadratic equation with roots alpha comma beta. Right. Now look at this alpha comma beta. That means x equal to alpha comma x equal to beta. These are the two roots. Here also take this value to the other side. Then x minus alpha will be equal to 0. Take this value to the other side. Then x minus beta will be equal to 0. Multiply both values. X minus alpha into x minus beta will be equal to 0. Now expand the brackets. Here we have x square into x into beta means minus beta x minus alpha x plus alpha beta equal to 0. Right. So here we can write down x square minus alpha plus beta x plus alpha beta equal to 0. Now, when roots are alpha comma beta, from that we can find the quadratic equation. So, right. So this equation is important. We have to use this equation to develop quadratic equations in the next problems. So, first write down this, then draw a red color box around this quadratic equation. So we are going to use this directly to the next problems, right? So in this manner, we can find the quadratic equation when the roots are given. Right. Then write down the next example. Write down, find the quadratic equation. Find the quadratic equation with roots. Find the quadratic equation number 3. Find the quadratic equation with roots alpha over beta, comma beta over alpha. With roots alpha over beta, comma beta over alpha. So these are the two roots. Right. Now look at this. This is also we can do in the same process. Take this to the other side. X minus alpha over beta equal to 0. Here we can write down x minus theta over alpha equal to 0. Multiply both vectors. X minus alpha over beta into x minus beta over alpha equal to 0. Right. Then I expand this. X into x square, x into this minus beta over alpha x. This one into this minus alpha over beta x. This one is to this minus into minus plus alpha over beta into beta over alpha equal to 0. Right. Now we can simplify this x square minus beta over alpha plus alpha over beta x plus 1 equal to 0. Right. Okay. Now we can simplify. Take the common denominator of this term x square minus, if you take the common denominator is alpha beta. Here multiply by beta, multiply by alpha. So alpha square plus beta square into x plus 1 equal to 0. Now multiply both sides by alpha beta. Then this equation will become alpha beta x square minus alpha square plus beta square x plus alpha beta equal to 0. Right. Now here roots are alpha over beta, comma beta over alpha. Right. So in this way we can develop a quadratic equation when the roots are given. Right. I think you have understood that part. Now let's use this result for the next part. Write down as summary in red color. Then in there write down finding the quadratic equation. Finding the quadratic equation when the roots are given. Right. So look at this. From the previous part, we know that when x equal to alpha and x equal to beta, we have developed the quadratic equation, right? So in the previous part, we have developed that when x equal to alpha and beta, we know the quadratic equation is x square minus alpha plus beta x plus alpha beta equal to 0. So if the roots are given, we can write down the quadratic equation in this way, right? Here roots are alpha plus alpha and beta. So x square minus addition of the two roots alpha and beta x plus multiplication of the two roots. So sum of the roots into x plus product of the roots, right? So this equation, we saw this equation in the previous part. Now we are using this as a theory, right? So write down x square minus, here we have, if the roots are alpha beta, here we have alpha plus beta. That means sum of the roots. Here we have sum of roots into x, plus here we have alpha beta, that means product of roots. Right. So this is a theorem. This is a standard theory. We use this theory to simplify the problems. So if the roots are given, if the roots are alpha comma beta, right? So if the roots are alpha comma beta, we can find the quadratic equation like this. Okay, right. Now let's do a small question using this formula we have developed. Right. Now look at this. Let's write a small question. Now, previously we have done, when the roots are given, we have developed the quadratic equation of a, right? Now we can use this formula directly, and we can develop the quadratic equation. That is easy when we are doing problems, right? Now write down, find the quadratic equation with roots. Find the quadratic equation with roots alpha over beta plus 1 and beta over alpha plus 1, with roots alpha over beta plus 1 and beta over alpha plus 1. Right. Now we can use the previous formula directly. Right. The formula was x square minus sum of the roots. Sum of roots means this plus this. So alpha over beta plus 1 plus the second root beta over alpha plus 1 into x plus the product of the roots alpha over beta plus 1 into beta over alpha plus 1 equal to 0. Right. Now let's simplify this. Now we have x square minus, here if you take the common denominator is alpha beta. Common denominator is alpha beta. Then if you multiply this by alpha, we will get alpha square, this by beta, then beta square plus 1 plus 1 means 2, multiply by alpha beta, 2 alpha beta into x plus simplify the brackets, this one into this, alpha over beta into beta over alpha, that is equal to 1, plus this one is to 1 alpha over beta plus 1 into beta over alpha plus 1 into 1 is 1 equal to 0. Right. Now we can write down x square minus, so here alpha square plus beta square minus plus 2 alpha beta, that is the expansion of alpha plus beta square. If you expand this, you will get alpha square plus beta square plus 2 alpha beta over alpha beta into x plus let's simplify this one. Here alpha over beta plus beta over alpha plus 2, same as this term, right? So here we can write down alpha square plus beta square plus 2 alpha beta over alpha beta equal to 0, right? So here then we can write down, right? I will erase the first part. Then we can write down x square minus alpha plus beta square of the whole thing over alpha beta into x plus this part we can simplify as alpha plus beta square of the whole thing over alpha beta equal to 0. Now we can multiply both sides by alpha beta. Then the final answer will be alpha beta x square minus alpha plus beta square x plus alpha plus beta square equal to 0. Right. So this is the final answer. Right. So in this way, using this formula, we can directly find the quadratic equation when the roots are given. Right. Now write down a point. Write down a separate point in red color. Write down if there are equal roots. Write down if there are equal roots for two different quadratic equations. If there are equal roots for two different quadratic equations. For two different quadratic equations. That means when they are in the standard form, their coefficients are directly proportional. That means when they are in the standard form, their coefficients are directly proportional. Right. So let's see what is meant by that. So I am taking a quadratic equation x square minus 7x plus 12 equal to 0. So we know that here the roots are 3, 4. I will take this one as number 1. Right. Then I will take another quadratic equation 2x square minus 14x plus 24 equal to 0. Then I can separate this equation into factors. I can write down 2x square minus 14x means 6x minus 8x plus 24 equal to 0. Now here I can take 2x out of the brackets. Then x minus 3. Here also I can take minus 8 out. Then x minus 3 equal to 0. Then separate the factors. X minus 3 into 2x minus 8 equal to 0. So separately equal these two factors to 0. Then x equal to 3. Here 2x minus 8 equal to 0. That means x equal to 4. Right. So if you simplify this equation, the roots are also 3, 4. Here also the roots are 3, 4. Right. So here I'm going to write down 2x square minus 14x plus 24 equal to 0. Here roots are 3, 4. Right. Here also roots are 3, 4. Now I will compare these two equations. First equation, and now look at this first equation x square minus 7x plus 12 equal to 0. Here we got roots 3, 4. This is the first equation. Now second equation, we have 2x square minus 14x plus 24 equal to 0. Here also roots 3, 4. Now I can compare these two equations. So if you look at these two equations are in the standard format. First we have the x square term, then x term, then the constant term. And the roots of these two equations are equal. Roots are equal and they are in the standard form. Now if you compare the coefficients, here coefficient is 1, minus 7, 12, 2, minus 14, 24. If you compare the coefficients, first one, the coefficient of x square term is 1. In the second equation, coefficient of x square term is 2. That is half. Right? In the first term, coefficient of x is minus 7. Coefficient of x, second equation, coefficient of x is minus 14. In the first equation, the constant term is 12. In the second equation, that is 24. Right? So if you simplify this is equal to half. Minus 7 minus 14, that is also equal to half. Minus 12, 24, that is also equal to half. So if you look at this, the coefficients are not equal, but they are directly proportional. Right? The coefficients are directly proportional. In the corresponding terms, in these corresponding terms or the related terms, the coefficients are directly proportional. So if this is a very important relation when we are using this for the next part. Right? So if there are two, if there are two quadratic equations with the same roots, if there are two quadratic equations with the equal roots and they are in the standard format, then the coefficients of those two equations are directly proportional. That is a standard relation we are going to use, right? So under this one, write down coefficients of corresponding terms are directly proportional. Coefficients of corresponding terms are directly proportional. Right. Now look at this. Look at this. So I'm going to take a quadratic equation ax square plus bx plus c equal to 0. Here roots are alpha comma beta. I'm going to take this one as number 1. So here roots are alpha comma beta. Now I'm going to develop the quadratic equation using these two roots. You can develop the quadratic equation with these two roots. So quadratic equation with roots alpha comma beta. We can develop that using the previous formula. So then we can write down x square minus the sum of roots alpha plus beta x plus the product of roots alpha beta equal to 0. So I will take this as number 2. Right. So if you look at these two quadratic equations, here also the roots are alpha comma beta. Here also the roots are alpha comma beta. And these two quadratic equations are in the standard format. First we have x square term, x term, then the constant term. Right. Now if you compare these two equations, they are in the standard forms and their roots are equal. Therefore, from the previous relation, we can say that the coefficients of these equations are directly proportional. Right. Here 1. So we can say that coefficients of these two equations are directly proportional. Right. Therefore, we can write down coefficient of x square is a. Here x square, coefficient of x square is 1. That is equal to coefficient of x is b. Here the coefficient of x is minus alpha plus beta. Equal to here coefficient is c. Here alpha beta. So the coefficients are directly proportional. Now I'm going to take the first relation. This one as number 3 and this one as number 4. Now right. Now look at this. Right. So from right. So from number 3, I can write down a over 1 equal to b over minus alpha plus beta. Right. Minus alpha plus beta. Now I can cross multiply these two. Therefore, minus a alpha plus beta equal to b. Right. So now I can take the minus sign here. A alpha plus beta equal to minus b. Right. Alpha plus beta equal to minus b. I am going to write the answer here. Now I can divide both sides by simple a. Therefore, alpha plus beta will be equal to minus b over a. Now this is a standard result. This is a standard result. Alpha plus beta. Alpha plus beta means the sum of two roots. The roots of these equations are alpha comma beta. So alpha plus beta is the sum of two roots. So sum of roots we can directly find the sum using this formula. Right. Now from number 4, we can write down a over 1 equal to c over alpha beta. Then a alpha beta equal to c. Then we can write down alpha beta equal to c over a. Right? Alpha beta equal to c over a. So this is also a standard relation. that this is the product of two roots. Product is equal to COA, sum equal to minus BOA, right? Here B is the, if you take this quadratic equation, B is the coefficient of x term, A is the coefficient of x square term, and C is the constant term. So we can directly say that sum of roots equal to minus coefficient of x term divided by coefficient of x square term, and the product of roots equal to constant term divided by coefficient of x square term, right? So these are the standard results, right? Now write down. So I think this is clear, right? Next, write down in red color summary and the pattern. Summary and the pattern. Right? Write down in red color summary and the pattern. Right. So I'm going to write down the standard quadratic equation ax square plus bx plus c equal to 0. Here roots are alpha comma beta. Now we can, here roots are alpha comma beta. Now we can write down the addition sum of roots directly, alpha plus beta, that is equal to negative coefficient of x term b over coefficient of x square a. So this is the first result, number one. Second one, product of roots alpha beta, that is equal to constant term c over a. This is the second result, right? Okay, now we can find out if this result is correct or not. So let's take an example. So here x square minus 7x plus 12 equal to 0. Here the roots are 3, 4. Now if you use the first result, alpha plus beta. Alpha plus beta means the roots are 3, 4. Therefore 3 plus 4 should be equal to minus b over a. Here b means coefficient of x term, that means minus 7. Minus value of that over a means coefficient of x square term 1. So here this is equal, right? 7 equal to 7. Right. Same way we can find out about this relation. So here alpha beta means the roots 3 into 4. Here c is the constant term. Here constant term is 12. And the a is x square term, that is 1. So this is equal, right? So if you take the example, this result can be shown from that. Right. So we are going to use this result directly in the next questions. Right. I think this is clear. Now we can move to the next part. Okay. Now write down the first question. Write down the first question. First one, write down. Write down if the roots of the equation. Write down a question. First question. Right. If the roots of the equation ax square plus bx plus c equal to 0. If the roots of the equation ax square plus bx plus c equal to 0 is alpha comma beta. Is alpha comma beta. Then find the quadratic equation. Then find the quadratic equation with roots 1 over alpha comma 1 over beta. Then find the quadratic equation with roots 1 over alpha comma 1 over beta in terms of simple a comma b comma c. In terms of simple a comma b comma c. Right. Now look at this. Let's find the solution. So they are given a quadratic equation ax square plus bx plus c equal to 0. Here the roots are alpha comma beta. Right. Here the roots are alpha comma beta. So that means we can write down our relation addition of sum of roots alpha plus beta equal to, we can write down that directly, alpha plus beta equal to a negative coefficient of x term, that is b, over coefficient of x square, that is a. Right. So I will take this one as number 1. Next, product of roots alpha beta, that is equal to constant term c divided by the coefficient of x square term, that is a. I will take this as number 2. Right. Now, using this, we can find the quadratic equation with roots 1 over alpha, comma 1 over beta. Right. Now look at this. Write down quadratic equation with roots 1 over alpha, comma 1 over beta. We can directly write down x square minus sum of roots 1 over alpha, comma plus 1 over beta, x plus minus sum of roots into x plus product of roots 1 over alpha into 1 over beta equal to 0. Right. Then simplify this, x square minus alpha plus beta over alpha beta into x plus here 1 over alpha beta equal to 0. Now multiply both sides by alpha beta, then alpha beta x square minus alpha plus beta x plus 1 equal to 0. Right? Plus 1 equal to 0. Now here we know alpha into beta, that is equal to c over a, and alpha plus beta equal to minus b over a. Therefore, we can write down instead of alpha beta c over a x square, c over a x square minus alpha plus beta means minus b over a x plus 1 equal to 0. Plus 1 equal to 0. Now, let's simplify this. Right, let's simplify this. C over a x square minus into minus plus b over a. So we can write down c x square over a minus into minus plus b over a x plus 1 equal to 0. Now multiply both sides by a. Then final answer is cx square plus bx plus c equal to 0. A equal to 0. Here roots are 1 over alpha, comma 1 over beta. Right. That is the answer. Right. So in this way, you can directly find the quadratic equation with using the given roots. Okay. Now, so I think that is that types of questions are easy. When the roots are given, you can find the alpha plus beta value. Then you can find the alpha beta value, alpha into beta value from the given equation. Then you can use the formula to find the quadratic equation. Right. Next part. Next, write down another question. Write down. So this question is a little bit different from the question we have done. Right. Write down. If the roots of the equation, write down if the roots of the equation ax square plus bx plus c equal to 0. If the roots of the equation ax square plus bx plus c equal to 0 is alpha comma beta, then from that derive the quadratic equation. Then from that derive the quadratic equation. Right. Then from that derive the quadratic equation with roots. Derive the quadratic equation with roots 1 over alpha, comma 1 over beta in terms of a comma b comma c. In terms of a comma b comma c. Right. So if you look at this second question, it is very similar to the first question. It is very similar to the first question, but there is a small difference. In the first question, they are asking to find the quadratic equation. In here, they are asking to derive the quadratic equation. There is a difference between finding and deriving. Finding means you have to find the quadratic equation from the first step by step, right? So uh, you have to find the quadratic equation from the beginning. From step by step, you have to find the quadratic equation. That is finding or proving the quadratic equation, right? Deriving means not doing that in step by step manner. Deriving means you have to use the given equation and convert that equation to the given equation, given roots, given equation with the given roots, right? So deriving means converting the given equation to the equation we want. Finding means you have to begin from the basic steps, and you have to simplify step by step. That is finding. Now we are going to derive. That means we have to convert this equation to the equation we want, right? So that's it. Here they have given ax square plus bx plus c equal to 0, and also alpha comma beta. That means x equal to alpha, x equal to beta. These are the two roots, right? So write down. Let's assume the algebraic relation. Let's assume the algebraic relation y equal to 1 over x. Let's assume the algebraic relation y equal to 1 over x, right? So I am going to convert x value to y value. That means I am going to convert the variables of this equation. So here the variable of this equation is x. A, B, C are constants. X is the variable of this equation, right? Now I am going to use a relation where y equal to 1 of x. That means I am going to convert the x value to a y value, right? So let's see what will happen if you convert this, right? So when x equal to alpha, there are two values that x can take. That is alpha and beta. Alpha and beta are the two values that x can take, right? So when x equal to alpha, then y will be equal to 1 over alpha, right? So when x equal to beta, then y will be equal to 1 over beta. So what is, if you look at this result, these are the two roots that we want, right? These are the two roots that we want. So using this relation, we can convert x value to a y value. Then from that, we can get the two roots that we want, right? So 1 over alpha and 1 over beta are the two roots that we want. Right. Then write down that. Here write down the two roots that we require. Right. So I'm going to convert the equation. Now look at this. So I'm going to use this algebraic relation y equal to 1 over x. Right. Now look at this. When y equal to 1 over x, when y equal to 1 over x, then x equal to 1 over y. Right. If you cross multiply, when y equal to 1 over x equal to 1 over 1. Right. Now we know that they have given this equation. They have given that ax square plus bx plus c equal to 0. This is the equation they have given. The roots are x equal to alpha, comma, x equal to beta. This is the first equation. Now we can convert this x value to a y value. Here y equal to 1 over x. Here x equal to 1 over y. Now I'm going to convert it. Therefore, instead of x, I can write 1 over y. A into 1 over y square plus b into 1 over y plus c equal to 0. Plus c equal to 0. Here roots are, instead of x, I can write 1 over y equal to alpha. Here 1 over y equal to beta. Right? Equal to beta. right? Now I can simplify this. A into if you take the square 1 over y square plus b into 1 over y plus c equal to 0. Right here roots are 1 over y equal to alpha, comma 1 over y equal to beta. Right. Now I can take the common denominator. I can take the common denominator in here. So common denominator is y square. Here a plus by plus cy square. This will be equal to 0. This will be equal to 0. Then we can write down roots. So you can take the reciprocal of this. Then y equal to 1 over alpha. Here y equal to 1 over beta. Right. Now multiply both sides. Multiply both sides by y square. Then you will get here you will get cy square plus by plus a equal to 0. Cy square plus by plus a equal to 0. Here roots are y equal to 1 over alpha, comma y equal to 1 over beta. So this is the equation we need, right? The roots of this equation is 1 over alpha, comma 1 over beta. So this is same as the previous equation we saw in the previous question, but the method is different. We use a deriving method. In the previous question we used a proving method, right? Deriving means converting the given equation to another equation, right? So if you look at this final answer, now look at this. Right? If you look at this final answer, there we have cy square plus by plus a equal to 0, right? Here roots are y equal to 1 over alpha, comma y equal to 1 over beta, right? So here we know y is a variable, right? Y is a variable, so we can write down any letter instead of y. So here we can write down any letter instead of y. That equation will does not change, right? So changing the variable and changing the substituting another variable and just writing another letter for this variable is two different things, right? So here I can write down instead of y, I can write down t. So ct square plus bt plus a equal to 0. So the roots are t equal to 1 over alpha, comma t equal to 1 over beta. Likewise, we can just change. We can just change the letter, right? You can just change the letter. That doesn't change the meaning of the equation, right? That doesn't change the meaning of the equation. We can just change the letter. In the previously, we have used the algebraic expression to change the variable into a different variable, right? Here we don't. Here we are not doing that. Here just we are just changing the letter, right? That is two different things. So here we can write down instead of t x, we can write down x cx square plus bx plus a equal to 0. Roots are x equal to 1 over alpha, comma x equal to 1 over beta. So this is the final answer, right? Okay. So